Namaste and a very good morning to all of you. I welcome you to my channel, The Outlier. In today's presentation, we'll be looking at how to do a credit risk analysis using a tool which is known as Statcraft. But even before I introduce you to the tool Statcraft, let me introduce you to the data set that I have before me. As you can see here, this is the data set that I have, in which I have credit rating details of the customer. The first customer has been a bad credit risk. His age is 36 years. He belongs to the middle income class. When it comes to his credit cards, he has 5 or more credit cards. Education level has been college, and car loans has been more than 2. He has more than 2 car loans. So this is about the first customer. If you look at the second customer, you have his demographic details. You also have the credit risk details of the second customer. Let me scroll down. You have roughly 2,464 individuals here. I've got 2,464 individuals. This is the sample size of my data set. This is good enough for me to build a good model. Let me investigate what are the variable levels that I have in this particular data set. Firstly, credit rating. This is a very important variable because I want to use this particular variable as the dependent variable. I've got bad credit risk and good credit risk. These are the two groups that I have. When it comes to age, this is a scale variable. So obviously there will not be groups here. In income level, you have high income class, low income class, and middle income class. So these are the 3 buckets of customers that you have. You have some customers who belong to the middle income group, second class customers who belong to the high income class, and the third customers who belong to the low income class. Let's look at credit cards. There are 2 groups here, 5 or more credit cards. A person can possess either 5 or more than 5 credit cards. And the second chunk here involves those people who have less than 5 credit cards. When it comes to education level, either a person can pass college. You have one group of people who have passed college. The second group of people have passed their high school. Let me look at the last variable, namely car loans. Here I've got 2 categories. That is, people can have more than 2 car loans. That is the first group of people. The second group of people are those people who have none or 1 credit card. So this is about the data description. I want to import this particular data set. And once I import this particular data set in Statcraft, then I can go ahead and do my analysis. Let me close this file. I've got Statcraft here. Now, there are many things that can be told about Statcraft. This is a tool which is made in India. Now, there are 2 or 3 important advantages of Statcraft. Firstly, it is not a programming tool. It is not a programming language. Here, it is a menu-driven software. Right? It's a menu-driven software. It is completely GUI-based. So all those people who are not very comfortable with programming will really enjoy Statcraft. Secondly, because we are not writing a lot of codes and such things, the time that we take to execute a project is reduced drastically. Thirdly, it is very easy and simple to learn. Fourthly, you don't need to know any of your Python programming. You don't need to know any of your R or R coding or C++ programming. You don't need to have a background in any of these programming languages. You can still go ahead and use Statcraft. Fifthly, when you run R or when you run Python, you have to install the libraries. Sometimes it gives a lot of error. It is not easy to install many of these libraries. You have to spend a lot of time in debugging the errors. In Statcraft, you don't need to install one single library because all the libraries are already installed. That is one of the major advantages of Statcraft. With this being said, let me just give you a demonstration of how Statcraft works. This is the menu. Let me click on the menu. you can see it has 10 to 15 different options listed out here. Now, this is self-explanatory. If you want to do any advanced modeling, you can choose any of these options like regression, clustering, machine learning, time series, survival analysis, dimensionality reduction, and such things. I want to import my data set. So let me go to the option data and choose the option import. It takes some time because I'm running this on a local machine. Once it displays the window, I can go to the relevant location. I can go to my C drive or D drive and import the file that I'm interested in working. Now it's asking me to provide a table name. I will say credit rating, right? So this is the name of the table. I have to click on this option, upload file. I can go to D drive. The name of the file is tree_credit. So this is the file, as you can see, tree_credit, which I want to import. I can just click on open, and within the span of milliseconds, it imports the data set that I want to work on, right? Now you can just observe if all the variables that you want to work on are imported. I want credit rating because this will be my dependent variable. It is a string data type. It has correctly, Statcraft has correctly recognized that this variable is a nominal data type. I've got other demographic details like age, income, credit cards, education, car loans. All these variables I want to work on, right? Now that the data set has been imported, what I'll do is I'll just click on the option OK. Right, the data set has been imported. And once you click on the option OK, what Statcraft does is it displays the contents of the data set. So you're already familiar with this data set, so I'm not going to go over this data set again. You have credit rating. Within credit rating, you have a list of customers. Some of these customers have been bad credit risks, others have been good. And you have got all the demographic details. Now my data set is ready. Now, all that I need to do is run a credit risk analysis for this particular data set. Question is, how do I do it? Now, to do a credit risk analysis, you can just click on the menu here. Now, you have a whole lot of options. Let me scroll down. There is an item here called as machine learning. Let me click on the drop-down menu. They provide 3 different options as of now. The first item here is R part. Let me click on the option for R part. There are 3 choices that you can make. It asks for what is the analysis title. It is not mandatory that you provide this. You have to specify the dependent variable and the independent variable. Remember, when we are doing a decision tree, it is what we call as supervised learning technique, which means I have the dependent variable. I also have the independent variables. If you do not have the dependent variable, if you have just a set of variables, you may have to look at the similarity and such things and do an unsupervised learning. In my case, I have got my dependent variable, which is credit rating. I can just choose this particular variable, credit rating. I have to just click on the option plus. Let me go to independent variables and choose the remaining variables as independent variables. So this is all you need to do. As you can see here, you're not writing one single line of code here, right? You're not saying import NumPy, import pandas. You're not saying import TensorFlow, import Keras. That particular activity or list of activities itself is given up here. All that you need to do is you need to just choose the options, and once you choose these particular options, you can go ahead and run your analysis. Now I've got the options tab here. I can partition the data set or request for a confusion matrix. A confusion matrix is really important, and therefore let me choose the confusion matrix. Let me minimize this particular window. You can see at the bottom, it says either refresh or OK. Now I'm going to go ahead and choose the option OK. It's taking some time to execute the code. Right. Very, very interestingly, what Statcraft does is it returns the R code, which happens to be at the heart of all the analysis. It just gives you the code, the R code, which is running at the back end. Now, why does it give this R code? Because if you want to pull out this code and do some advanced level analysis, or if you want to customize this R code, you can do it, right? Those of you who are familiar with R code here, you know what does set.seed mean. You know how to import the data set. Right. Secondly, you also here in this particular instance, we are just converting these variables as a data frame. We are running a rpart function here, right? You don't need to do any, you don't need to keep in mind any of these things. Let's look at the output of the decision tree analysis. Now, what you're seeing here is called as a confusion matrix. I will interpret the confusion matrix here, but even before I interpret the confusion matrix, let me show you the plot. Look at the beauty behind this particular plot here. When you earlier saw the data set, you had around 2,500 observations. It did not make much sense, right? You can't process such a huge data set manually. You can't perhaps identify which is the important variable, which is an unimportant variable. But looking at this graphical display, anybody can make sense of what is going on in the data set. Let me just interpret this particular decision tree one by one. Now, right at the top, you see what is called as the parent node. This is nothing but the dependent variable that I had specified. And as you can see here, the majority class is being displayed. Always R displays the majority class in that particular node. Please be sensitive to two things here. Wherever you see a blue color node, that represents profile of bad credit risk. I repeat, a blue color node represents profile of bad credit risk. On the other hand, a green color node represents profile of good credit risk. That's what that's how we can interpret the decision tree. Decision tree highlights which is the majority class or which is the model class in that particular node, what is the sample size in that particular node, and what is the distribution, what is the proportion of bad credit risk and good credit risk. These are some important details that a decision tree displays. As I told you, this is my dependent variable. It has identified income. You can see here as dot factor of income, which means that income level of a customer is identified to be the first best predictor to classify an individual as a good credit risk or as a bad credit risk. Now you can see here, it has two different arms. The first arm, the arm that you see on the left-hand side, says yes. On the right-hand side, it says no. If you read the heading here, it says income equals low, yes, which basically means that when you traverse this particular path, when you go through this particular path, you're looking at those people who belong to the low income class. Within the low income class, you can see majority of people belong to the bad credit risk. In this particular node, you have 22% sample size, 82%. Hold your breath. It's 82% of people belong to the bad credit risk. Only 18% of people belong to the good credit risk. But this is not the terminal node. This is what we call as the decision node. The eventual decisions are made based on the terminal nodes. It is not made based on the decision node. So I have to go to the next level here. After income equals low, you can see here, credit cards is equal to 5 or more. Credit cards is equal to 5 or more. Here it is yes, right? So when you look at this particular profile here, it represents those people who belong to the low income class and those people who possess 5 or more credit cards. So if an individual belongs to the low income class and possesses 5 or more credit cards, you can see 90% of such people tend to be bad credit risk, right? 90% of such people tend to be bad credit risk. Hardly 10% of them tend to be good credit risk. It's highlighted this particular node, the terminal node, in a dark blue color. Dark blue color is very, very important because that is very, very rich in the category of our interest. The category that we are interested in is identifying bad credit risk. So this is a very, very powerful rule. And in a span of milliseconds, you'll be able to identify the first rule to classify bad credit risk. That is, people who belong to the low income class and who possess more than 5 credit cards belong to the bad credit risk. Let me look at this particular box here, this particular node. This it says is good. What is the profile of these individuals? You have to trace back the path here. Low income class and those people who do not have 5 or more credit cards. Those people who belong to the low income class and who do not have 5 or more credit cards, you can see that 62% of them tend to be good credit risk. So these are 2 important rules that you can pick up just by looking at the decision tree. On the right hand side, you have other important nodes. Let me just interpret this node here. Please look at the variable here, low income class, but it says no. It obviously means that here on the right-hand side, this represents the profile of people who do not belong to the low income class. They either belong to the medium income class or they belong to the rich class. Now, when a person belongs to the middle income class, what you see here is 30% of them tend to be bad credit risk, 70% of them tend to be good credit risks. Let me just go all the way down. So you have those people who belong to the middle income class or rich income class. And second important variable is 5 or more credit cards they possess. And the income is specifically middle. The income class is specifically middle. And the age is less than 28 years. When a person's age is less than 28 years, he belongs to the middle income class. He possesses 5 or more credit cards. Then you can see here almost 82% of them tend to be bad credit risks. So this is the way you can interpret the rest of the nodes as well. A decision tree is a very, very powerful approach to understand the profile of individuals. You can use this for other case studies as well. You can use this in other scenarios as well. A decision tree is a non-parametric approach towards profiling individuals. So when the relationship is non-linear, you can definitely use a decision tree. When you have a lot of missing data, you can use decision tree. It takes very little time for you to clean the data set. So these are all some of the big advantages of decision tree. And nextly, when you have independent variables which show a lot of correlation, then again, you can use the decision tree. Now, this is a high-level interpretation of what a decision tree is telling us. We have not looked at all of these important items in the output. Let us just explore this one by one. Let's first look at variable importance. You can look at the variable importance table here. This tells the hierarchy of importance of the variable. What do I mean when I say hierarchy of importance of variables? What I'm able to learn from this particular table is which are the top 4 best predictors in identifying whether a customer is a bad credit risk or whether a customer is a good credit risk. Right at the top, you see income is the first best predictor. This is the key driver or to identify whether a person is bad or good. It has a value of 3.90. The second most important variable is number of credit cards that a person possesses. Thirdly, you have car loans. Fourthly, you have age of a person. So based on a person's income, number of credit cards that he possesses, number of car loans and age, we can classify an individual as bad credit risk or good credit risk. This is important. Let us also look at the confusion metrics, right? This is the code for the confusion metrics. The code, I'm actually interested in looking at the exact value of the confusion metrics. Now you can see here in the column, what you see is the predicted category. That is predicted bad and predicted good. My apologies, it is the other way around. In the row, you have the predicted category, that is bad and good. And in the column, what you have is the actual. Actually, in the data set, what is the count of bad credit risk and good credit risk? This is what you have. So if you take the total of 626 plus 394, roughly it comes to around 1020 individuals. So in your data set, you have 1020 bad credit risks. And out of these 1020 bad credit risks, 626 bad credit risks have been correctly identified by the decision tree model that we have built. So roughly that comes to around 62%. So in identifying bad credit risks, our accuracy level is 62%. It is roughly 62% because these diagonal elements here represent the correct classification. Look at good versus good. It is 1,354. 1,354 out of 1,444 individuals. If you just take the sum of 90 and 1,354, roughly it comes to 1,444. Out of 1,444 good credit risks, 1,354 individuals have been correctly classified as good credit risks. So in identifying bad credit risks, my model is doing a good job to the extent of 61%. And in identifying good credit risks, the model is doing a good job of to the extent of 93%. So this tells you something about the quality of the model. Now it reports a lot of other important metrics as well, very, very important metrics like what is the precision, what is the recall, what is the F1 value, what is the prevalence, what is the sensitivity level, specificity level, what is the true positive rate, what is the true positive value, what is the false positive value, and such things. But I would like to draw your attention to a very, very important table, which is called as complexity parameter table, right? This is called as the CP table or complexity parameter table. CP basically stands for complexity parameter. Now, what CP does is it refers to the trade-off. It refers to the trade-off between the size of the tree and the error rate to help prevent overfitting. We obviously want a highly accurate model, but to get a highly accurate model, you can go on splitting. But the problem with the splitting the model is that it may hurt the generalizability of the model. So to prevent overfitting, what we do is we prefer a smaller tree, right? So we have to do some kind of a trade-off here between the size of the tree and the error rate. This is very, very important, and CP statistic helps us do that. These large trees with lower error rate are penalized in favor of smaller trees. So this is a general rule of thumb. Now, when you look at the CP statistic, how do you interpret CP statistic? There's a general question that I keep getting. Please keep this rule of thumb in mind. Smaller values of CP always encourage larger trees. I repeat, smaller the value of CP, it always encourages larger tree. But the problem with a larger tree is that larger tree many times results in overfitting, right? If you sort of if you sort of specify a very, very low CP value, what you may end up having is basically a tree which results in overfitting. Large values of CP encourage smaller trees. Now, out of all these numbers, what I would say is please look at the cross-validation error, right? We obviously want the cross-validation error to be the least. And in the first step, you can see 1. In the subsequent step, right, as you go on splitting, the error rate sort of reduces from 0.65 to 0.5 to 0.48. So in step 4, when you have a CP value of 0.01, this is the complexity parameter. When you have a complexity parameter of 0.01, your cross-validation error is the lowest, and therefore you can choose the optimal value of CP as 0.01. Right? So this is a very, very important table. Now, you can also see a graphical display of this particular information. Many times it helps to look at the graph. Now you can see here in the y-axis, you have the cross-validation error. And in the x-axis, in the lower x-axis, I have the CP metric. And in the higher x-axis above, I can see the size of the tree, right? Now, as the CP value increases, the cross-validation error is, now my apologies, it's the other way around. Now you can see here, the CP value is sort of reducing here. It is not increasing, it is reducing from 0.13 to 0.031. It further reduces to 0.01, right? So the CP value as you move from left to right is reducing. But if you look at the top, the size of the tree is sort of increasing. As I said, this graph is very, very useful because it helps you identify what is the ideal CP value, right? Let me repeat this point. CP, when we are looking at CP, we are actually trying to look at, we are trying to balance, we are trying to achieve some kind of a trade-off between the size of the tree and the error rate to help prevent overfitting, right? So this is a demonstration that I wanted to give on Statcraft. So this brings me to the end of today's presentation. I thank you very, very much for watching this particular video. I request you to subscribe to my channel and hit the like button. I'll see you in my next video. Thank you very much.